Hey, this is the intro to Python game coding. I am Mr. Smucker, your host, and also perhaps your teacher, your previous teacher, or your future teacher. This is me right here. Hello. And today we're going to be going over the basics of game development, especially the coding side. So this is all going to be coding. You don't need to know a dang thing coming into this. So if you're like, I don't know what I'm doing, you're in the right spot. Okay. Hopefully by the end of this, you'll have a better idea of what programming is and how that affects game development. So, real quick, I'm going to show you what we're going to be creating in this video. So I'm going to hit run right here. This is in Python, by the way. It says UHS Game Jam, rock, paper, scissors. Enter rock, paper, or scissor. Let's say rock. I always choose rock. Player chose rock. Computer choice rock. Oops, there needs to be an I here. Choice rock. Computer choice rock. So it's a tie game. Okay, this is what you're going to be making. CHOI. Choice. Choice. All right, now it should work. Rock. Oh, we won this one. Okay. Rock and paper. Okay, so first of all, the entire program that we're going to make fits into 27 lines. And by the end of this, here, take a look at this. I'll give you a second. Just see if you can kind of deduce what's going on. It's okay if you can't. In this 27 lines, there's the entirety of rock, paper, scissors. There's generating a computer move, taking user input, printing things to the screen like this. And by the end of this video, you're going to know how to do all of it. And I'm going to also tell you and show you things that you can further explore, give you ideas for other games. So sit back, relax, and enjoy. If there's anything that you're not crystal clear on, please go back and rewatch that section or use other resources. Programming is not something that you can just kind of know and just like, you need to know exactly what's going on at every line of code in order to create your program. So if I go too fast, feel free to rewind. I do that all the time. I Google things like crazy. That's part of the process. Okay, learning what you don't know. All right. So let's start with what are we even using to program? So I'm using a website called replit.com, replit.com, and this allows you to code in your web browser. Now, this is not the coding language. You can hit start coding. I already have an account. You might have to log in. This is the host. This is what hosts the programming. I'm going to hit create up here. I'm going to make a new Python. You can type Python in here. Python. There it is. And you can name it whatever you want. You can name it like my first program. Yeah. And then you hit create. So we're programming in the programming language called Python. Python is extremely user-friendly, which is why I'm using it here and why a ton of people use it. Let's see. Top programming languages 2022. Python, number 1. Right there. Everybody uses it. I prefer C++ and Java, but that's just me. But you'll find what you like if you keep on coding. You'll figure it out. Okay, so how does code work in the first place? So before I even code anything, I am going to open up handy dandy Microsoft Paint. So if this is your document that you've been working on, it works just like a text document. You know, you write in text, and just like a human would, the computer reads top to bottom. Doesn't necessarily read left to right, but you'll see. But it starts at the top, and it starts reading instructions one time, and it starts executing them one at a time, right? So if this first one says, let's say we do something like this. Let's say here's our play area, like here's a yard, right? Here's our little dude, and we say go up, go up, go right, go right, go down, and go left. This is what's going to happen. The computer is going to start from the top and read go up. Is going to move our guy up. and then it's going to read up again. It's going to move him up again. And then it's going to read right. And he's going to go right. It's going to read, oops. It's going to read, here, if I can grab it. It's going to go right, right? You see what's happening? It reads it one at a time. Go right. Go down. Boop. And go left. Right. Very straightforward. He started right here, but then he went doot, 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 like that. Okay. That's all fine and dandy. Very nice. Very nice. What if instead it was up, 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 just a whole bunch of them, right? You'd start at the top of the page. Let's say he starts down here, and you'd move up, 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 up. Oh, what happens? This is not good. He's out of the screen. This would cause an error, which we'll see. Code can run and code can error, okay? If there's an error, you have to find out why there's an error and fix it. A big part of programming is problem solving, right? So what's the problem here, right? If he goes off the top, that's an issue, right? And the computer will say, whoa, your guy's out of the screen, right? You'll have to go in and say, oh, I have too many ups. I need to fix this, right? Alternatively, there are other kinds of errors where like maybe you misspell something. Instead of up, you put UO because O is right next to P. It'll read this one, then this one, then this one, then this one. And it'll get here and it'll say, dude, what the heck are you doing? Like, I don't know what this command is. Please specify. So those are errors, right? And so while you're programming, you're going to run into all sorts of errors. So let's take a look at what this looks like in programming. If I could open it up. Let me see. Am I being recorded? Yes. Okay, I am. All right. So this is where you can type all your stuff. The first thing I'm going to show you about Python is this thing called print. Print's really nice because it puts things into the console. Now the console, you have two things. You have your code document, and you have the console. The console is where everything prints out to. It's called printing because a long time ago they would physically print out a piece of paper, but you print things to the screen and they show up in the console over here. So if we print out our guy, he'll show up in the console. So if I type print and then I put something in here, such as hello, it puts hello in the console. Okay? So let me walk you through exactly what's happening here. Print is a function. It's like a command to the computer. It tells the computer, hey, you need to do this thing that's been pre-coded, right? Somebody else coded what print does, and you just get to use it. You don't have to know how it works behind the scenes. All you need to know is that whatever you put in the parentheses right here, you say print, and then it has two parentheses. Whatever is in the parentheses gets put on the screen or the console, right? So if I say hello, oops, that's outside of it, right? If I say hello everyone, right? And I hit run, it's going to print hello everyone, exactly how I typed it. Now, the astute among you may have noticed that I put these little tick marks. Okay? Watch what happens if I don't have these little tick marks. Ooh, we're getting some red squigglies, invalid syntax. Okay, here's an error, right? This is that second kind of error that I talked about. I've misspelled something. There's syntax we have to follow, right? It's like the grammar of programming. So let's read this error together. In the file main.py, which is the one we're working in right here, it says main.py. On line 1, which is the line we were coding on, print hello everyone. Okay, here it's pointing right here at everyone. It says invalid syntax. Okay. So we have to figure out why it's invalid syntax. Okay. It's because print needs a string of characters. Okay? In order to make a string of characters, you need these little ticks. Okay? The little quotes. You can also use double quotes if you want to be fancy, but I like single quotes. This works too. Just the same. Doesn't change anything. So essentially, what this is when you have just a whole bunch of characters, right? A, B, C, D, E, F, G, right? Python has no idea what you mean by this. It's like, okay, you type some crap. How does it differentiate between print and the thing you want to print? I mean, there are the parentheses, but like, no, that's what you're sending to the function called print, and like, use quotes. Okay, quotes tell the computer this is not code. This is literally the text. A, B, C, D, E, F, G. This is not code. This is not code. This is not code. Not code. These are characters. Okay, this is text. As soon as you remove the quotes, it becomes code, right? Watch this. Anything I put in the parentheses prints. I have to pass in a string. This is anything in a quote is called a string. It's a string of characters. We have the quotes here. Okay, quotes. If I put print, we're printing the string print, the string of characters, the text print, P-R-I-N-T, and it puts print onto the screen. I could even put print with these in here. Now, this is really weird. We have a print function that takes whatever is inside of the parentheses and puts it on the screen. And the thing inside of the parentheses is the text print open parenthesis, close parenthesis. And it puts print open parenthesis, close parenthesis. Hopefully this makes sense. Now, alternatively, you can put anything in here, honestly. You can put any kinds of characters. You can go like this, put numbers, all sorts of stuff. Very nice. Puts it on the screen. All right. Now, what if we want things on like multiple lines, right? What if we say hello? Oops. Hello. I'm going to copy this. Control C, Control V. We have hello, hello. Watch this. Hello, hello. If I change the second one and I hit run, it prints the second one. Very nice. I'm going to copy and paste this like 100 times. Right? And it starts from the very top. It does the first print, then the second print, then the third print, then the fourth print. You can see that hello, 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 right? Okay. That's printing. So what I want you to do right now is, if you haven't already been following along, go to replit.com. Open up a new Python document. Make sure it's Python. Not Python with turtle, not Python with anything else, just Python. It should be empty. It should say, not sure what to do, blah, 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 blah. There should be nothing over here on the side. I want you to print out your name, okay? And if you can't get it to, and you're getting errors, I want you to figure out why. That is half of programming, figuring out why something doesn't work, okay? And when you've done that, I guess pause the video here, and then unpause when you're done. Okay, awesome. If you did that, good job. If you didn't, go ahead and do it. Go ahead and do it. Good job, though, if you already did. Now we're going to talk about numbers. We talked about text, but we can also do math with Python. Very nice. Very nice. Check this out. Oh, actually, before I talk about that, let's talk about input. I feel like input's another useful function. So we have print right now, right? We have print that puts something onto the screen. There's another function called input that takes something from the screen and puts it somewhere. Okay? No, I do have to talk about variables first. Okay, we'll get to that in a second. So in Python, you can create these little buckets that hold information. And this is where programming becomes incredible. You need to know what variables are. Okay, so if you need to watch this 2 or 3 times to really have it soak in, feel free. Please tinker around and save stuff into variables and do all sorts of stuff after I'm done going over this, because that's how you learn and that's how you make some cool stuff. There's all sorts of cool stuff you can do. So this is what a variable is. You can imagine a variable is a little bucket, okay? And this bucket has a name let's say my var for my variable. And you can put one thing in the bucket, no more and no less. There's always one thing in the bucket. Let's say I put the string smuck. I am Mr. Smucker. Actually, I'm going to put smucker. I put smucker in the bucket. Okay? You can go to your variable and look inside. You can use your peepers and say, what's in the box? What's in the bucket, right? And you can look inside, and there's one thing. Okay? This is like, imagine instead of a bucket, it was a house, right? You have the house number, right? Mine's 220. And we have the Smucker family in the house, right? I am the value in the house, and the house number is the name of the house, 220 Winterbrook Drive. Don't drive to my house. So watch this. I can go into Python and say my var equals, I'm going to put something in the box, Smucker. Okay. Let's look at this. We have the name of the variable, which is the box, right? And we put one single thing inside of it. We put the string of characters, the string, Smucker, into the box. Okay? Hopefully that makes sense. We're taking, this is the value, this is the name. We can make another variable called my second var and equal that to, I don't know, Martin. So now we have two boxes, right? We have two boxes. We have the my var and my second var. And this one has Martin in it. Okay? All right, cool. We can put things in buckets. Who cares? Right? Well, watch this. This is some cool stuff. Actually, I'm going to keep this one. Oops. Remember how we said print? We said print, and then we can put like Smucker in here, and this will print out the word Smucker. If we put, this is the string Smucker, by the way. This is the text Smucker. If instead we don't have quotes and we use a variable name, my var, watch this. What do you think will happen? What do you think? Take a second. Print my var. There are three answers that usually come up. It prints my var, the text my var. It errors because there are no quotes, or does it print Smucker? Which one do you think it'll do? It prints Smucker. Let's figure out what's happening. Let's go step by step. First thing, here I'll delete this over here. The first thing that happens is we make a box, we make a variable, we make a variable called my var, and we put the text Smucker inside of it. All right, done. We're done with this line. Haven't printed anything to the screen yet. Nothing's happened. Second one, my second var equals Martin. So we make a new box called my second var, and we put the text Martin in there. Awesome. Now we have two buckets, two boxes. Nothing happens on line 3. It's empty space. It just skips over that. Then we come down to print my var. When the computer sees print and then a variable name, look how it highlighted that. It says, don't print the text. Don't print the text of the variable. Print whatever's in its bucket. And Smucker is inside of its bucket right here. So it says, okay, what's the value of my var? It's Smucker. So I print Smucker. If I were to put my second var, what would print out here? What would print out here? Martin. What if I said my third var? We get an error. There, you did not make a bucket. It's looking for a bucket. It says, this ain't the right one. This ain't the right one. We're out of variables. There's no variable called my third var. We haven't made it yet. So we get this error. Line 4 of main.py. Look, error name. Name my third var is not defined. Okay? I'm going to show you one more thing with variables, and then I want you to pause the video and play. Okay? I want you to write some stuff, see if you can do this, see if you can do that, see if you can, play around with it. Instead of saying my second var equals Martin, what if I said my var equals Martin? What's going to happen here? Well, remember how I said, oh, and I got to print out my var. Remember how I said variables can only hold one value. Oops. Watch this. Here's my box. It's called my var. And we got Smucker. What do you think is going to happen when we try to save Martin into my var? There are a couple things that people normally think. It makes another box with the same variable name. It overwrites the value in there, or it saves both of the values. What do you think is going to happen? What's your best guess? Only Martin was printed out. Let's walk through what happened here. In the first line, we have my var equals Smucker. So we have my var, that's the variable name, and we put Smucker in its bucket. Then we go to the same bucket that already exists, the same variable, and we save Martin into it. This completely overrides what was already in there. In fact, crossing it out doesn't do it justice. We need to actually delete it. And it overrides it with Martin. Okay? And now that my var has Martin saved in it, when we print out my var, it prints out Martin. Hopefully that makes sense. So here's what I want you to do. I want you to pause the video right now, and I want you to play, okay? One thing I want you to try to do is see how you can save and print out values. What happens if you print out a variable, then you change it, and then you print it again? So something like this. We have, what if you did this? I want you to try this out, and I want you to see what happens. And I want you to follow the code in your brain, line by line, and see what happens. If you want to draw a picture, that works too, okay? This is part of programming, okay? You have to try things. You have to think about what the heck's going to happen. Programming is not a skill or a science. It's a puzzle, okay? And that's what I want you to have fun doing. If you like Sudokus or you like nonograms, I love nonograms. Or you like any sort of puzzle, like logical puzzle, this is what programming is, okay? So play. Pause the video right now and play. See what happens with this. All right. Hopefully you are back. Let's see what happens when we hit play. It prints out Smucker, and then it prints out Martin. Hopefully you can figure out why this happens. And if you can't, I want you to draw a picture, okay, and figure that out. If you can, awesome. We're going to go on to the next thing. So we've been talking about strings of characters this whole time, text, okay? And text is really nice, right? But what if we want to use numbers, okay? I'm going to do a quick, let me see if I'm still recording. I'm still recording. Hello. Here's an important thing to know. This is a fundamental programming thing, okay? There is a difference between the number 5 and 5 like this, the character 5. There's a fundamental difference, okay? I'm going to pull this back up, and I'm going to delete all this, and I'm going to go like this. Let's say x, that's our variable name, x equals 5. And I'm going to say z equals quote 5, okay? This 5 that's being stored into X is the number 5, okay? This is the number 5. This represents 5 things, okay? This is the idea of 5. It's how many fingers you have on your hand, how many toes you got on your foot. It's how many jumping jacks I can do before I get tired. It's the number of wheels plus 1 on my car. This, however, the one with the quotes around it, is not the number 5. It's just a squiggly line. Okay? This is the character 5. Okay? It holds no logical or numeric value. Okay? You can't do addition with this. Okay? Because this is a squiggly line. If you had a 5 and a 4, you could do addition with these. But if you have a 5 and a 4 that have quotes, these are 2 squiggly lines. It makes no sense to add them. They don't represent numbers. They represent characters. It'd be like saying banana plus apple. That makes absolutely no sense. But 4 plus 5 makes sense. So let's look at this in code. If you have quotes around something, it is a string. It's a string of characters. If you don't, and you have a number, it's the actual number. It's the logical value of it. Okay? So I'm going to hit run, and this works, right? The number 5 is stored into X, and the string 5 is stored into Z. Okay? And I'm going to print both of these out. Oops, not print H. Print X, right? And print Z. Take a second and think about what's going to happen here. What's going to happen? Are they both going to print out? Is only one of them going to print out? Is it going to error? Let's see. Oh, they both print out. Incredible. Interesting. So on this next line, before they print out, I'm going to do this. I'm going to say X equals, if I do 1, it would replace the number. So instead, I'm going to do X equals 5 plus 1. Actually, I'm just going to do this up here. X equals 5 plus 1, okay? And for this one, I'm going to do 5 plus 1. What's going to print out each time? The first one actually does the math because these are actually numbers. The second one is the literal text. 5 space plus space 1. Okay? And that's what gets printed out over here. But you're saying, Mr. Smucker, why don't you do this? Aha! There we go. We have 51? How does that work? Why? But the astute among you will notice that this is a 5 and a 1 glued together. Okay? If you add numbers, they're called integers or floats, depending on if they have no decimal or a decimal. If you add integers together, if you add numbers together, they actually add together. If you add strings together, they just squish together. Watch this. What if I did hello and everyone? Everyong. It squishes them together and stores them into this Z variable. Okay? It's like going like this. Hello, everyone. Okay? Now, what happens if you do this? Oops. What happens if you do something like this? Will this work? We get an error here. Okay, let's see. What line? Line 2, so that's this line. Z equals 5 plus 1. Type error, unsupported operand types 4 plus. Int and string. Okay, so let's see what this is saying. unsupported types for plus. Okay, so that means we've given it incorrect types on the both sides. Int and string. Okay, so it's saying we're trying to add an int and a string, and that is not supported. We can't add an int and a string. Okay? You can only add strings together, and you can only add ints together. Hopefully that makes sense. So from here, what I want you to do is I want you to try as many different math equations as you can. I want you to do some math and do something with addition, subtraction, multiplication, division, which is a slash. And if you can figure out what the percent sign does, bonus points to you, okay? To figure that out, I want you to Google Python, what does percent sign mean? Okay? And that's for you to figure out, okay? So play. Pause the video here and play, okay? And when you're done, come back. If you're just watching this and you're not coding along and you're not taking time to get used to the material, it's not going to stick. So it's much more worth your time to pause and play. And in fact, after this play session, I suggest you take a break. Pause the video, go get some water, watch a YouTube video, read a book, play 10 minutes of video games, and then come back after you've played. Okay? This will help the information solidify. Programming is tough. There's a lot to learn, but you do it in chunks, okay? Pause the video here, and when you come back, we'll get back to it. Okay, I'm going to get my water. Aha, here it is. Delicious, refreshing water. Okay, so this is awesome. We have the ability, welcome back, by the way, welcome back. Let's see, let me see where I am on this. Okay, we did how instructions are read. Oh, this is important. I should have said this earlier. Computers are fast but dumb, okay? Computers are fast but dumb. Computers will read all your instructions, but they have no idea what you want to do. So you have to be extremely explicit, right? Which is why you get so many errors like this. Like, of course you meant 5 plus the number 1, but it doesn't know that. So you have to be extremely explicit. Okay. Just thought I'd throw that in there. We did prints, we did variables. Okay. Yes. Okay. Now we get to the cool stuff, the really cool stuff. This has all been building blocks. Okay. Now we can get to things that actually help you make a game. Only go past this point if you are solid, like 90%, with everything we've covered so far. Remember when I was talking about input? We have print, which puts something on the screen. We also have input, which takes something from the screen. Okay? And I had to go over variables first. Watch this. I'm going to print enter your name. Now watch this. I'm going to hit run, and it says, enter your name. Okay. And then I press enter. Oops. Okay, I get an error. This program doesn't actually do anything. So of course I get an error. It's because there's the slash, but anyway. If I want to take user input, I can say input. I'm then going to say thank you afterwards. Watch this. Where did the thank you go? Shouldn't there be a thank you? And I should just be able to type in here? Watch this. The program printed out, enter your name right here. Then it paused and it's waiting for user input. Notice how, do you remember, let me remove this real quick. Do you remember how it had that little, this little like triangle looking 3 pixel thing? This means your program has stopped. Oops. Look, there's no 3-pixel thing. It's waiting for your input. I'm going to type Bob. As soon as I hit enter, it says thank you. It waited for user input. Now, it might not immediately you might not immediately see why this is useful, but you will in a second. Watch this. Do you remember how we saved a string like Bob to a variable? Right? You could do something like this. Print enter your name. Then you make a variable called my name and you put Bob into it. Then you print thank you. Perfect. It doesn't ask you anymore. Bob is a string. Okay? When you type something into the console over here, for input, it turns whatever you typed into a string and replaces the input function with what you typed. This is a fairly confusing concept for a lot of people when they start out, but let's go through it line by line. I'm going to hit run. It says enter your name. This pops up because of the first line, enter your name. Now, the computer is trying to create a variable called my name. It's trying to create a variable called my name. Right? My name. And it's trying to put something in there. But the thing it's trying to put in there is what you type. Okay? And that's from input. I'm just going to write in. And that's from input. So until you type something, it's waiting. And it hasn't put anything in there. So if I type Bob, I haven't hit enter yet. As soon as my finger hits enter, it puts Bob, the string Bob, in the my name variable. Bob. And that's what happens. Watch this. The input essentially gets replaced with what you typed in. I typed in Bob, so it becomes replaced with what I typed as a string, Bob. And then this executes. Put Bob into my name, right? The input turns into whatever you typed in, okay? We can use this in a million different ways. I'm going to print you entered the name in a colon. I'm going to put a space. Then I'm going to put a plus and I'm going to put my name, okay? I want you to take time and work through line by line in your brain or on a piece of paper what's going to happen to this. This is a little bit of a jump, so it's okay if you don't get this right off the bat. Okay, I'm going to give you some time to work it out. Ready, go. Pause the video, come back whenever you're ready. All right, welcome back. So the first thing that happens is it prints enter your name. Then it gets your name from the input and saves it as a string into my name. So now you're looking like this. Yep, you did exactly this. I'm going to get rid of this. And now you have a variable called my name with Bob in it. Okay? Then you print thank you, which pops up right here. Then you print the string, you entered the name, and you print my name right next to it, which is the variable. And remember, when you print a variable, it prints the value stored in there. So let's look at this. You have Bob stored in my name. So it says my name, which has the value Bob stored in it. And it adds it together with this. So it joins these together like this. So it's going to print you entered the name Bob. Okay? Oops. My name. Let's see. I'm going to hit run. and I type Bob, and I hit enter. Thank you. You entered the name Bob. Any name I enter, corn. You entered the name corn. For the best deals in computer hardware, come to Radio Shack. You entered for the best deals in computer hardware, come to Radio Shack. That's pretty cool. You can do a lot of stuff with this. You can make a quiz game. You could make rock paper scissors, which is what we're gonna make. You could make Battleship with this. You're gonna need some other stuff for Battleship, but I'll go over that in a little bit. You can make so much stuff with just this. Okay. So pause the video here and play. Okay. I want you to play with prints, inputs, variables, and numbers and strings. Okay, that is what I want you to play with. Make something, okay? This is for fun, okay? Make something cool. What can you make with this, okay? And come back when you're ready. Let's see, okay. Okay, so welcome back. Some of you might have tried to get numbers as input, okay? I want you, if you did that, if you tried to get numbers as input, I want you to go over and Google Python how to get numbers as input. Okay? And I want you to try to figure it out without me. Use literally any resource. Okay? You can use YouTube videos. You can use tutorials. I love W3 School. W3 School. Python int input. Oh, int. Okay. You'll have to figure out how to use this, okay? This is part of programming, is I want to do this thing, and I don't really know how to do it, but I know what's wrong with it. And then you just Google stuff, and then you figure it out. That is what programming is. Throughout college, I did computer science in college. This is like 80% of what I did on my homework, right? And this is what 80% of working in the computer science industry is like. You just Google crap until you figure out how to do it. That's it. And it's solving a puzzle. So figure that out. I'll give you a little hint. It uses something like this, but you need to figure out how to use that. Okay? Awesome. Okay. So the next thing that we're going to do is conditionals. Okay? And conditionals are kind of weird. Conditionals are kind of weird. But they allow you to do a lot of powerful stuff. So I'm going to get rid of all of this. Let me start out with an example in English. Let's say you only are going to go on a walk if it is not raining. So here's you. Yay! Here's you. Here's the weather. And here's if you walk. That's you walking. Awesome. That's the sidewalk. All right. So if it is raining, let me write this out. If it is raining, then you won't walk. If it is not raining, you will walk. This is something that we can capture in a computer. Okay? Let me get a little more space. Okay. So I'm going to, instead of drawing some pictures, I'm going to say, is it raining? Is it raining? No. And yes. If it's not raining, then we will walk. If it is raining, then we won't walk. Okay? This is a conditional. This is called branching. right? We ask a question. Is something the case? Is it raining? No? Then we're going to do this. Yes? Then we'll do this. You can also think about this as just saying raining, true, it is raining, or false, it is not raining. Okay? We can use this in programming. We can do this through an if statement. If raining, I'm sorry. If not raining, right? If not raining is true, if it's not raining, we're going to walk. And if it's false that it's not raining, which means it is raining, right? If it's not raining, then it is raining. Then we won't walk. Okay? So in Python, this looks something like this. If raining, if it's raining, we're going to not walk. Else, we're going to walk. Okay? Let me do this. Ooh, let me do print. That would actually help. So let's walk through what's going on here. We're checking some condition. Is it raining? If it is, we're not going to walk. We're going to print out not walk. Else, otherwise, if this condition was false, it doesn't do the first one. It does the second one. Otherwise, go on a walk. Okay? This is called a Boolean. Okay? It's spelled like this. This is a type of variable. Okay? This is like a string. Oops. This is like a string. And this is also like an integer. It is a type of variable. It's a value. It's either true or it's false. Okay? There's no other value that a Boolean can be. It's either true or false. 1 or a 0. Yes or no. Okay? These are all trues or falses. Okay? So when we look at an if-else statement, this is the conditional statement. If you have a true value in here, it will run the first one. And if you have a false value in here, it will run the second one. Okay? Now let's talk about syntax real quick. Python is very, very specific with how it likes its syntax. Okay? When you create an if statement, you need parentheses. Okay? You need these parentheses. And inside of it, you need a condition. Then you need these 2 dots, the colon. Okay? This says everything that follows is part of this if statement. Okay? Now, notice I also tabbed this in. Python requires you to tab in the things that fall under an if statement. So if I did this, this would technically not be attached to the if statement. Now it is. Now it isn't. Now it is. Now it isn't. Now it is. Now it isn't. Now it is. And you can put a whole bunch of stuff under an if statement. Okay? You can put all these, right? You can have a whole bunch of code. You can even have an if statement in an if statement if you wanted. So let's see what happens real quick if we put in true. If I put true right here, let me go like this. If I put in true right here, if some condition is true, which true is true, it's going to print not walk. If the condition appears false, which it's not, it will run the else statement. So watch this, run. It prints not walk because the condition up here is true. If I put false, it will run the else statement, right? Now, you can put variables in here too. Let's say I make a variable called is raining. Okay. This is my variable. Is raining equals true. True is a value, right? We're going to put true in the is raining bucket. Now notice it doesn't have quotes around it. This would be the string true. This is the value true that we want to store into here, okay? So if we put is raining, and is raining is true, we're not going to go on a walk, okay? If I change this to false, is raining is false. So it's not raining. So we'll go on a walk. Walk. Because we have the variable here, it doesn't take the name of the variable, it takes its value, okay? And when we go back to this game, look at this. We have these gigantic if statements. All it does is condense down to a single false or a single true, okay? And you can also do something like this. Is raining equals true. If is raining is equal to true, print not walk. Okay? Quick side note, there's a difference between equals and equals. Okay? Equals assigns. It puts something in the bucket. Double equals checks, is this value equal to this value? Okay? And it itself turns into either true or false. Okay? So let's see. Is raining is false. So is raining right here, when I hit run, gets replaced with false. And does false equal true? No, it doesn't. So the whole thing gets replaced with false. Okay? So because this is false, the else statement runs. Okay? Do you see how this is starting to become a puzzle? You have to walk through the logical steps like Sudoku. Thanks for sticking with this. This is some weird stuff. Okay? You can also do stuff like this. Okay? I'm going to change this to A and I'm going to change this to B. Actually, I'm going to change this to the condition was true. I'm going to change this one to the condition was false. Just a little easier to read. False. Let's say we have, let's say we do something like this. X equals 5 and Y equals 10. If X is equal to Y, print out the condition was true. Otherwise, print out the condition was false. X is not equal to Y, right? Because X is 5 and Y is 10. So they are not equal. So essentially what happens is this changes to a 5. This changes to a 10. And it checks, is 5 equal to 10? Nope, that's false. So then false is in here. And so if it was true, then this one would run, but it's false, so the second one runs. Okay? You can also do if X is less than Y, or greater than, or equal to, right? And it changes into true or false all the way down, okay? The condition was true. X is in fact less than or equal to Y. Okay? That's awesome. That is some powerful, powerful stuff. There's one more specific thing I want to talk about with conditionals, and then I'll let you play, okay? What if we had 3 variables, z, and z equals 100, okay? What if we want x to be the smallest number, y to be in between x and z to be the biggest number? We can have something like this. X is less than y, and y is less than z. Okay? This is getting into algebra territory. So if you hate algebra, sorry. Hopefully you like it after programming. I actually hated math in high school, like hated it. And then I did programming in college. I was like, this is the coolest crap I've ever seen in my life. So watch this. If you have 3 times 4 is greater than 6 plus 8, you do this. You do this side, then you do this side, then you check the whole thing, right? So 3 times 4 is 12. Is 12 greater than 14, right? This is false. This is not true, right? Same sort of thing down here. We have x, y, and z, okay? So we have, let's see. X equals 5, y equals 10, z equals 100. And we want to see if x is less than y and y is greater than z, or y is less than z, okay? We only want this line to print out if this entire thing is true. If both y is greater than x and z is greater than y, okay? So let's do this. Let's replace these one by one. So x is 5 and y is 10. So we have 5 is less than 10. So is 5 less than 10? Yes. So this is true. We have true. And z is, or y is 10 and z is 100. 10 is less than 100. So this is true. Then we have this and. We need both conditions to be true. We need both x to be less than y, and we need y to be less than z. Both have to be true, and both of them are true. Let's say x was 50. 50. 50 is not less than 10. So this would be false, right? But we did 5. So because, let me get a little more space, because both of these are true, this is the same thing as one of these operations. This asks a question. Are both of these true? Yes, they both are true. So this entire thing gets replaced with true, okay? And because it's true, the first condition runs. Print. Okay? Okay. What if we only needed one of these to be true, right? What if we had y equals 110 and we had the same thing, right? Y is less than z, okay? I'm going to change this. Instead of, I'm going to do x is less than y or y is less than z, okay? Let me get this. Select. Or y is less than z. We only need one of these to work. Either x is less than y or y is less than z. If either of these work, we're going to print out the condition was true. Okay? Oh, and this is 110. Okay. In fact, they could both be true. We need at least one. This will turn into true if at least one of them is true. So let's do this. X is 5. Y is 110. Is 5 less than 110? Yeah. So this is true. And we have or y, which is 110, is less than z, which is 100. This is 110 less than 100? No, so this is false, right? Let me get some more space. So this is false. And we need true or false. We have true or false, right? The first condition or the second condition is true. This one's true. So we got one of them. That's good enough for us. That's good enough for us. So this whole thing turns into true. We need this one or this one to be true. And this one's true. So the whole thing turns into true, right? Let me see. The condition was, get out of there. The condition was true, right? This runs, okay? In your code, this replaces just how this replaced, okay? And let's look at the rock, paper, scissors example. Actually, before we do that, I want you to pause and play. Make me something that you have a variable called age. Age equals some number, 10. I want you to make me a bunch of if statements that say, if you're less than 4, you're a toddler. If you're less than 10 but greater than 4, then you're a kid. If you're above 10 and less than 20, you're a teenager. If you're above 20 and less than 65, you're an adult. If you're above 65, you're a senior citizen. If you're above 100, you're dirt or something. I don't know. You're dust, right? Old as dirt, old as dust. That's what I want you to try to do. Okay? Then we'll come back and we'll talk about how all of this fits together in rock, paper, scissors. And then we'll go through one final example. I think there's just only one final example. Yeah. Yes. Okay. I will see you when you are back. Okay? Pause and play. I'm going to go run and get water. Okay? I'll be right back. Hey! All right. By the way, if this is a lot, you don't have to do all this in one day. You don't have to do all this in one sitting. You can take the information, play with it, take a break, come back later. Okay? Um, I'm going to give a short tangent about how study and practice works with the brain, and then we'll go on to um, the game jam example and stuff. So, I am taking guitar lessons right now, okay? And there's a lot to learn. And for a really long time, what I would do is I would sit down for an hour and try to just brute force the whole hour. And it was terrible. It just never really worked out for me. And instead, what my teacher suggested I do is I do it in 15-minute chunks, 10 to 15 minutes, and then I take a break. I let it soak in my brain, and then I come back and do something else. And then I take a break, and then I come back and do something else. 10, 15-minute chunks. So if this is a lot for you, that's okay. Programming is tough, and it's not something that you can just pick up and know how to do in like an hour, right? It takes playing and experimenting and creating, and it's a very creative process. And it requires some push on your part, but it also requires a lot of creativity and exploration. And I think that if you're not feeling overwhelmed right now, or you're having a great time and you can't wait for more, by all means go on. But if programming and game development or design or anything like that is something you're interested in, but it's tough for you right now, that's probably a lot of you. It was for me. Um, just take it in chunks. You don't have to do everything in one day. There are like a million days in your life. Well, there aren't actually a million days. Let's see. Let's say you live 100 years. Let's say you live 80 years. Let's say you live 80 years, and there are 365 days in each year. That's 29,200 days. Okay? Let's see how many hours that is. 24 hours. Let's say you spend um, half half an hour each day. Um, let's see. Let's see. 20 24 20 that's 148 no 1 oh my gosh, I can't do math. I need 120. I need half of 1/24. That's 1/48. 1/48 of each day, right? And you, let's say you're 15. So let's do 65. You can spend 500 hours of your life if you do a half hour every day of programming. That's 500 hours you spend. 500 hours. Just a half hour a day. That's a lot. That's probably more than I've ever coded. Um, anyway, I digress. Take it in chunks, okay? You'll figure it out and enjoy it, okay? It's a creative process. For fun, I'm making a Sudoku solver. I take it here and there and do a little bit, do a little bit. You want to make a game? Make a game. Do fun stuff. Be creative. Okay. After your break, come on back. Welcome back. Okay, let's take a look, and I'm going to give you a couple seconds, pause the video, and look through and see if you have a better understanding of what different parts of this do. Now, we haven't gone over everything, but take a look. See what you recognize, and then I'll point out some key parts. I'm going to take a sip of water, and I'm going to let you go through and read these lines, all 27 of them, and I want you to see if you can figure out what each one does. Love me some water. Life energy. Let me make sure I'm still recording though. Yeah, I'm good. I'm good. I'm good. Okay. So right off the bat, print statements. We got print, 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 print. You should know what that does. You should see how it works over here. Okay? Also, input and variables, right? We talked about that. This is how you get the user input. That's how I typed rock. That's how I typed rock here. We got these prints that take both text. I used a comma here, but you can use a comma or a plus. And the variable name player choice, so whatever they typed in, right? And we got the computer choice. We did not talk about this yet, which is what I'm going to talk about. This is the last thing that we're going to cover. We have an if statement, an if statement, and an if statement with these gigantic conditions. And we'll go over those in a little bit. And then we just have a single print statement in each one. And that's it. That's rock, paper, scissors. Much easier to think about now, isn't it? As opposed to this wall of text. Okay? So, if you want, you don't have to do this right now because we're going to do it later. Take a second and read this. Okay? Draw this if statement out on a piece of paper. And see if you can figure out what it does. Okay? Now, this gives you a hint, but I want you to work through these, okay? Now, I will say, parentheses act the same way that they do in math, where the thing inside of them happens first, and then the other stuff happens. So if I have something like A is greater than, or let me just use numbers. 5 is greater than 3, and, 5 is greater than 3, and 2 is greater than 3, or 9 is less than 10. This is how this is sorted out. Let me make this bigger. 5 is greater than 3. That's true. And 2 is greater than 3. That is false. Or 9 is less than 10. That is true. This whole thing, false or true, or means only one of them or both of them need to be true. So this is true. And we have true and true, which is, you need both of them for an and, which is true. Awesome. So go through this one, write it out on a piece of paper or program it, and these are the two variables that you're using. Okay, now I'll let you in on a little secret. Computer choice is either going to be rock, paper, or scissors. Okay? It's going to be the text rock, paper, or scissors. Player choice can be literally anything. Okay? So run through these in your brain if you want to, but we'll come back to it later. Okay, now we're going to talk about random. Okay? Random's an interesting one. You can create numbers by typing them in. You can create numbers by sending them into the console, right? Or you can have the computer randomly generate a number. Okay? Now the thing is, random number generation doesn't come built into Python. Okay? Somebody actually made a file called random.python, and they filled it with all of these useful random functions. Okay? I haven't gotten into what a function is, but just know that it's similar to print or input, where you call the function, you type the name of it, and it will do something for you. It's already coded. Okay? And it's full of these super useful functions. And one of them is random.choice. Okay? We're going to use random.choice and randint. Okay? Random.choice and random.randint. Okay? I think it's randint. Let me see. I don't even know what it's called in Python. Okay? I don't use Python. I use Java and C++. Randint. It is called randint. Okay? And say I didn't know how to use it, I could go to W3 schools and like look through this. Okay? I need to import random, and then I do this, and then this, blah, 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 blah. And you can read through all that stuff, but we're not going to do that. I'm going to explain it to you. Okay. Let's start with random choice. Notice, actually, no. We're going to start with randint. Notice how undefined name random. First of all the other functions looked something like this with just some name and then parentheses. This one has random dot randint. This means it's pulling from a file called random with all those functions. Remember? It's like you have a file down here called random.python that some dude made that you're going to steal all the functions from. So you need to grab that, okay, and pull that into your program. And the way that you do that and get access to all of their functions is by typing import the code random, okay? Import the file called random. And on your computer or on Replit, they have a hard drive with all of these libraries, they're called, right? Libraries of code, all these functions that you can use. And you can import them as you wish to use them. So you can say, okay, go to the random that I imported, and use the randint function. Now this stands for random integer. Okay, generate me a random integer. Okay, I'm just going to hit run, and we get an error. Randint. Randint. There we go. So I'm going to hit run, and there's an error. Okay, this is a different error. Line 3, type error, randint, missing 2 required arguments, A and B. What does that mean? Well, remember with print took some text, right? Well, randint takes 2 numbers separated by a comma. Okay? So I'm going to say 1 and 10. I'm going to hit run. Nothing prints out. We have no print statement, so nothing happens. But a random number was generated. Okay? There was a random number that was generated. And this random number is between 1 and 10. Okay? So watch this. Let's say I have a variable called x, and I set it equal to whatever random.randint generates. Okay? Let's say it generates 7. It replaces itself with 7, and 7 is stored into x. Okay? A lot of people, when they're thinking about this for the first time, they will think, this whole function call is stored into x, and that's not true. The function call generates one number, like 6, and the number that was generated gets put into the bucket. Okay? So then we can print out whatever x was. Okay? So we import the code random. We call random with 2 parameters, 1 and 10. These could be any numbers. Save it into the variable x and print out x. 7, we get 7. Then we get 7. Then we get 7. Then we get 2. Oh my god, that was... What is that? 1 out of 10 to the third? That's, wow, that's a really small chance. That's like 1 in 1, 2, 3. That's 1 in 1,000 chance to get the same number 3 times in a row. 1 in 7. 7. Oh my god. 1, 10, 6, 3, 4, 7, 1, 8, 8, right? So what this does is it gives you a random number between your starting number and including it, 1, 2, blah, 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 all the way up to 10, all the way up to the number that you put as the last one. And that's super handy. That's super handy, right? What if you want to do like a dice roll? How would you do a dice roll? That's what I want you to pause and do right now. How would you make a variable called dice_roll and print out dice roll. What I want you to think about is, what are the possible numbers that you can get from a dice roll? And how would you change rand int to accommodate for that? So go ahead and do that. Welcome back. This is how you would do that. 1 and 6. You can roll a 1, 2, 3, 4, 5, or 6. And let's do that. We get a 6. We get a 1. We get a 2. We get a 1. We get a 5. We get a 6. We get a 4. We get a 6. We get a 6, right? How would you roll 2 dice, right? Pause and do that. Roll 2 different dice. Roll 2 different dice. This is how I would do it. Dice roll 2, and we have dice roll 1, equals this same thing. And then we say dice roll 1 plus dice roll 2. 3, 9, 6, 6, 8, 3, 5. Let's see if we can get a 12. 11, almost. 5, 9, 8, 8, 4. Okay. Too much fun. I'm having too much fun. Okay, so hopefully this makes sense. Now there's another kind of random that you can use, which is what we use in rock, paper, scissors over here. Okay? So check this out. Check this out. I am going to... What if we wanted, instead of getting numbers, we wanted to get a choice out of 3 things? Okay? 3 strings. Okay? Those are our choices. We can do something called random.choice. Okay? And for some reason, it's called a list, an array list. For some reason, we need these brackets in here, and everything that we put in the brackets are going to be the choices. So what if I said, hello, comma, everyone, comma, how, hello, everyone, chicken. Hello, everyone, chicken. Okay. If I do this, it's going to select a random one of these and store it into my variable x. And then I'm going to print x. Okay? Chicken. Everyone. Hello. Chicken. 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 Everyone. Everyone. Chicken. Everyone. Right? It chooses a random one of these. And that's what I used in rock, paper, scissors, right? So here's what I want you to do. I want you to play with this. And once you are feeling confident, let's see. Let me make sure I did everything. Yep, I did everything. You have, if you understand all this 90%, and you've been following along, you've been taking breaks perhaps, and you've been doing little code on your own, you have all the skills you need already to make your first game. You can code rock, paper, scissors right now. Okay? It's probably going to take you some time though, okay? And that's okay. That's part of the process. But the thing that you need to remember is, every time you push through something that's tough like this, and you work out the issues, and you solve the problems that crop up, you never have to solve those problems again, because you've already solved those problems. So say you wanted to make another game like tic-tac-toe. You already know all the stuff that you get, that you've learned from making this game, rock, paper, scissors. Now you're going to have to figure out how to do the grid and how to do the checks, and that's new stuff. But if you can do that, then you can make Connect 4. And if you can make Connect 4, then you can make Battleship. And it gets bigger and bigger and bigger. And the things that you learn from each one are going to stick with you, and you can build bigger and bigger games until you know so much, you can literally code any game you want. Now, it's going to take time and it's going to take effort, but if it's something you're interested in, it is so worth the effort, okay? And feel free to come back and look at any part in this video that you need to review, okay? You can ask me, and Google is your friend, right? How to make tic-tac-toe in Python, right here. Now, you could copy this, right? You can come down here, and it shows you all of this code, right? Oh, okay, I copy this, and then at the bottom, it'll show you the whole thing, right? What's going to happen if you just copy this? Right? And you put this in here. Sweet, you have tic-tac-toe, but you didn't make tic-tac-toe, right? The point is to learn the skills from it. So what I would suggest doing is before memorizing my code and copying and pasting it, I've already shown you it a good bit, but try to build it from scratch and go through the hard parts of creating it yourself. If you get stuck, Google stuff. If you get stuck, run through the code. If you get stuck, draw a picture. Okay? If you get really stuck, come and look at my code. Okay? See what you did wrong. See how you can fix it in a different way than how I did it. And then continue and finish it. Okay? And see how much you learn from it. That is what I want you to do. If you can finish this game jam and have a tic-tac, or not a tic-tac-toe, and have a rock, paper, scissor that you have programmed mostly from yourself, that is a win. And you can enjoy your pizza at the end of it, knowing that you created your own game. Sure, you didn't make the game up, and sure, you had me help you along, but like, you learned a bunch, and you can use that with any game that you make. Okay? So that's what I want you to do. When you're done, come in and look at how mine's different. And we're going to have a whole bunch of people that probably make rock, paper, scissors games. We're going to have people that make quiz. Ooh, that's another one. If you can do rock, paper, scissors, a quiz game would be really nice, right? So have like 10 questions and allow the people to answer, right? You could make a choose your own adventure text game. There's so many options that you can do. And I'm super, super excited to see what you can come up with. Because once you learn all of the little pieces and you get them in your brain, you can make anything you want, okay? So hopefully that was useful. In fact, I'm not going to go over this. I'm going to let you read through it, okay? I'm going to let you go and read yourself through it and figure out what it does, okay? And if you just copy and paste it, you're not going to learn anything, all right? So I want you to learn as much as you can because I know you got it in you because you're interested enough to come do this game jam. So I want to see what you can learn. All righty? Good luck.